Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest JEE test preparation platform. And today we are on the fifth session of your PYQs. And this is a really interesting chapter, very important chapter for your JEE Mains and also for your JEE Advanced. And in this session, what we'll do is we'll be covering your concepts. We'll be also doing your concepts along with your PYQs. So that way, it's going to be also a good revision for you. So that being said, I'm Muralidharan. I completed my MS in Electrical Engineering from one of the top ranking American university. I'm also an IITian who completed BTech from IIT Guwahati, 4+ years of experience preparing students for IIT JEE and other competitive exams. And I filed 25 patent applications in India and abroad. And students, if you are looking for a complete package for your JEE Mains and JEE Advanced preparation, it's going to be Unacademy subscription any day. And why do we say that? Because we have the best educators across the nation with whom you can attend daily live interactive classes on a very interactive platform with live polls and leaderboards, so that your learning becomes very interesting. And not only that, we also provide lots and lots of test series, along with which you will also be getting analysis using which you can improve upon your overall performance. And students, you will also get access to lots of live doubt clearing session, which is quite an important component for your JEE preparation. And this feature is also available on an Academy subscription platform. Not only that, it is available in a very structured manner, and in fact every fourth session will be a live doubt clearing session. Not only that, every program on an Academy subscription is all structured and it's well planned and it's taken in a very systematic manner. You will be getting live access to live doubt clearing session and quizzes and mega quizzes with every Unacademy subscription program. And not only that, students, moreover, what we provide is an unlimited access throughout the period. You don't have to worry about batch restrictions, etc. It's all taken care. There are no batch restrictions. You can attend as many classes as you want. You can enroll to as many programs as you want on an Academy subscription platform. And how do you avail an Academy subscription? Do log in and click on the left hand top corner extension bar, select plus, select IIT JEE as your goal, and hit on this get subscription button. And that's it. And post that, you'll be redirected to the payment page and your program selection page. So which one you should be going for? Let's say you are a 2021 aspirant, you should be going for a 6-month subscription, which is going to cost you near about 25,000. And let's say you are a 2022 aspirant or 2021 aspirant planning to drop, you may want to go for a 12-month program. A 12-month program is going to cost you less than 35,000, 34,650. And let's say you are a 2023 aspirant, you may want to go for a 24-month program, since it's a 2-year-long journey. How much is that going to cost you? 50,400 for 2 years. That's near about 25,000 per year. That's less than 70 rupees a day. Okay. And students, yes, we have started programs, as you know, for 2021 aspirants, and also for 2020 and 2023 aspirants as well. We have programs going on. We have hosted some of the programs by some of the best coaching institutes Vibrant Educators and also like Bansal Class Educators on our platform. So this is about Plus subscription, but we have also something beyond Plus subscription known as Iconic subscription. On Iconic subscription, you not only get access to all the features of Plus, but along with that, you'll be also getting one-on-one mentoring session, personal coaching from IIT and NIT alumni who are like the educators on our platform. So think about it, IIT and NIT alumni who have previously gone through this journey and have successfully cracked the exam will be guiding you in this process. So think about it, like they know the ups and downs in this journey, and they also know about the strategies and the way to get around the barriers, etc. So they will be giving you personal advices, personal coaching. They'll be guiding you with the motivational sessions to keep you running throughout your journey on Iconic subscription. So yes, students, it's going to be one of the best things if you can, if you're willing to afford it. And how much is a 6-month program going to cost you? 34,200, and a 1-year program is going to cost you 58,500, and a 2-year program is going to cost you 90,000 for 2 years. That is like 45,000 per year. And make sure you apply Murli Live code like be it you go for like a plus or an iconic subscription, or like any kind of plus iconic or also a combo subscription. It can be 6 months, 12 months or 24 months, any kind of subscription, so that you get maximum discount on your subscription purchase. Okay. And that being said, what is this combo subscription? Combo subscription is something that we recently introduced, where you can get both your IIT JEE preparation and CBSE board coaching at an economical price from the best educators across the nation, and it's going to be more economical than availing individual package. It can go as less than 90 rupees a day for 2-year subscription, less than 120 rupees a day for 1-year subscription. And make sure you apply Murali code here as well to get the best discount on your subscription purchase. Yes, discounts are also applicable on your combo subscription, and we do also have different combinations of combo subscription. We'll get to that at the end of this session. So yes, we have a question here. A long straight wire of radius A carries a current. Okay, now let's understand this question. It's a very easy question as such. So okay, there is a long straight wire of radius A and they carry a current. So this A is actually what radius. Okay. And they carry a current distributed uniformly over its cross section. The ratio of the magnetic fields due to the wire at a distance A by 3 and 2A. So here some hint has been given to you. Current uniformly distributed throughout its cross section or over its cross section. So what should be the ratio of the magnetic field at A by 3 and 2A? If you have understood, this is something related to your what law? Amperes. Okay, now let's get into this. See, here comes the thing. First of all, what is given to you? A current is uniformly distributed over its cross section. Okay, that means what is constant throughout the cross section? J. What is J? If you remember, if not, I'll remind you. It is a current density, and if you multiply with area, you will be getting the actual current, right? This is current density, which is uniform throughout the area, and if at all we multiply this current density with area, we will be getting, like let's say A dash or area 1, we will be getting some current I1, like within that like a particular conductor, etc. Now let's move on to the next thing. So first of all, we have to find out at A by 3. Okay, this A by 3 is that cross section here, but we are supposed to find what is going to be our magnetic field, right? This is inside this wire, right? So from Ampere's law, we can say that B dot dl integration is equal to how much? Like your mu naught into that of I1 in this case. Let's say it's loop 1, then this is going to be I1 in this case, right? That's it. Now we know the thing, and what are we supposed to do? First of all, what is going to be the area in this case? We are concerned about first of all mu naught into I1 to find out I1. I1 should be like how much? J, some J we just defined, into pi into, for this loop, what is the radius? R by 3, like A by 3 is going to be pi into A by 3 whole square. Easy. Next thing, B dot dl integration, right? And this is dl is how much? Your B we can assume to be outside, and what is the dl going to give you? Like 2 pi into A by 3. That's it. This gets cancelled out, and yeah, there we go. We have something like mu naught into J, and pi also gets cancelled out. Okay, and we have mu naught into j into a divided by 6 as b1. Let's keep it as b1 or a by 3, whatever like you would like to call it. Just let's throw that inside the bracket. Okay, now that's it. Now the next thing. Okay, next, where are we supposed to find out the field? In this case, the second case is at a distance 2a. At a distance 2a, right? Again, we are going to apply the same thing. We are going to say integration of b dot dl for loop 2, that is at a distance 2a from the center, is equal to mu naught into I2, and I2 is the total current in this case. Okay, so this is going to be little different. Just keep noticing, it's a very simple problem. If we are going to discuss about I2, what is the value of I2? Something like j into a 2, right? In this case a2, what is that a2? A2 is just this a, okay, into that of mu naught. Okay, you're getting this total term will be like into mu naught. Continue our equation, and a2 value is how much? Mu naught into j into pi a square, right? Total radius is a. Okay, now let's get on to the next thing. In this case, what is this loop or that line integral value? This circumference, how much is this circumference? 2 pi into r. R in this case is 2a, right? So it's going to be how much? 4 pi a. That's it. Now again pi gets cancelled out, rest remains as it is, and 1a gets cancelled out with 1a. This is going to be b2. b2 is how much? Mu naught into j into a divided by 4. This is equation number 2. Now, what do we need to find out? We need to find out ratio of magnetic fields due to this wire at the given distance, and the ratio is supposed to be b1 is to b2. Is that it? Are we supposed to find that? Yeah. In fact, we could have done something around the options. I don't know why didn't we do it. But anyway, let's solve this. So b1 is to b2 going to be how much? b1, as you know, is mu naught into j into a divided by 6. Mu naught into j into a divided by 6. And b2 is how much? Mu naught into j into a divided by 4. End of the story. Mu naught into j into a divided by 4. Okay. Now actually it's a very easy problem. If you are noticed that mu naught j cancelled out, this is going to be 2, this is going to be 3. What are we going to have? b1 divided by b2 is going to be how much? 2 by 3. Okay, this is going to be 3. That's it. Okay, easy problem. Yeah, 3 by 2 is given to count. It should have been less than 1, but there are 2 options in JEE that any sense doing that thing. Okay, now this is a very interesting question. So yeah, let's get on to the next question. Next question here we have, okay, here comes the thing. There is a charged particle of mass m and charge q. mass m and charge q. They are moving under the influence of uniform electric field E into I cap. Okay, as shown in the picture. Okay. Now, what do we have? We have a magnetic field along the B into K, that means outside direction. Okay, and what is happening? It is following a trajectory like this, right? What is being said? Then which of the following statements of A, B, C, D are correct? Multiple can be correct. We need to analyze each and every option. Okay, it's a very simple problem. Just to you will difficult. Let's get into the solution. As usual, it's a very simple problem. So first of all, what is happening? We have a particle with mass m and charge q. Okay. Okay. How much distance it has commuted to a distance? What is the initial velocity? Initial speed is v, final speed is 2. Okay, now comes the thing. Now we will be assuming that none of this velocity change is due to magnetic field. All of it would be due to electric field, because magnetic field is kind of like this in the outside direction and the velocity is like this. So if you are going to apply right hand thumb rule, going to be like this. Okay, it's going to be in this opposite direction, but this it is supposed to be. Okay. So velocity is like this, magnetic field is outside, it is supposed to be like this, right? Now your rotation is going to happen for your particle like in this direction. Okay, now the thing is, it does not affect your this thing, your velocity. It is assumed that it is just like acting like a centripetal force, that is not going to affect the velocity. All that velocity changes due to electric field. Okay, we need to assume this to solve this problem. Okay, so how much distance it has traveled to a distance? How much velocity it has increased? Initially it's v. I initial was speed, initial was v. V final was how much? 2v. And how much distance it has traveled? Like to a distance. Okay, and next we need to do one more thing. We need to write down the acceleration due to this electric field. Okay, electric field acceleration due to electric field going to be how much? E into q is equal to force, is equal to how much? Mass of the particle into acceleration. That means from both these terms, can we say acceleration is nothing but QE by m? Yes. Okay, we know this thing. Now if we know this thing, what is the next thing that we need to do? We need to apply Newton's equation of motion, which says v square or v final square is equal to v initial square plus of 2as. Here s is going to be this 2a, don't get confused, and here a is going to be this. Okay, v final is how much? 2v. So 2v whole square is equal to v initial v square plus of how much? 2 into acceleration is how much? QE by m into that of distance is what we have, isn't it? Distance is 2a, right, into 2. Okay, let's solve this equation. What would we get? 2v square, 4v square minus v square. So we'll be getting something like 3v square. So let's write it down quickly. We'll be getting something like 3v square is equal to, how much do we have? We have something like QE by M into 4A. So what are we supposed to actually find out in this case? Supposed to find out what is the value of electric field in this case. Okay, now let's get into this and find out. Just we need to find out what is the value of E. So from this equation, can we say something like this? Value of electric field, how much? 3 mv square divided by 4 QE. Okay. Now that's it. That's it. Back and see 3 by 4th of mv square by QA. Are we getting this? Okay, my mistake. It's supposed to be A. It's not supposed to be E. This is supposed to be A. Okay. Yeah, of course. Okay. Yeah, we are getting it. Now next, work done by the electric field at P is our rate of work done, not work done, but rate of work. Basically, what is rate of work done? dW by dt, isn't it? Let's call it as rate of work done. Rate of work done is how much? dW by dt, and it is supposed to be what? D into, like F into displacement divided by time. I mean, like differentiating it with time. Now in this case, observe this thing very carefully, that force, if it is a constant thing, it's basically ds by dt. That means rate of work done is how much? F into ds by dt, or ds by dt, how much is that? F into velocity. We have, what is this? Same as rate as work done. Okay, that is dW by dt. Now we should be using this value and finally getting the answer, right? We'll be doing the same thing. Now what we are going to do is, rate of work done by electric field at P is what we are supposed to find out. So let's do that. Okay, we are supposed to find out rate of work done at P. Okay, so at P, rate of work done is how much? dWB by dt, or dWE by dt. Okay, it's going to be how much? Force due to electric field into that of velocity at that point. Velocity at that point is, okay, what is force? Q into, if this particle has a mass m and a charge q, it's Q into electrical field into V. How much does that come out to be? Q into some 3 by 4 into mv square by 4, mv square by qa. Just writing it down, the same value that we just derived. So yeah, that's all we are doing. So q gets cancelled out. So what is the rate of work done by the electric field? It is supposed to be 3 by 4 mv cube by a. That's it. End of the story. There we have got, not yet, we are supposed to analyze the rest of the two options as well. Okay, so second option is also correct. Okay, actually some options are given over here, A, B, C, D. Among this you are supposed to choose. Few of them had field. Rate of work done by both the fields is 0. No, that's not true. We just found out one as some work done on it. So by the both is being asked. If by the both, if the rate of work done is 0, the velocity is not changing. Hence, it's not true. Now, the difference between the magnitude of angular momentum of the particle at P and Q is how much? Okay, angular momentum MVR, right? Calculate that as well. So at this point we are supposed to find out angular momentum. I think it's with respect to origin, right? How much is this supposed to be? It has a mass m. Distance is how much? A. So at P, what it is? M into V into A. Right? Let's talk about Q. L at, how much is this going to be? This again is like a particle of mass m, distance to A. Velocity how much? 2v. So m into 2v into 2a. So that comes out to be how much? LQ comes out to be 4mva. Right? We have P and LQ. Right. So yeah. Now what are we supposed to find out? Difference between the angular momentum, I guess. Difference between the magnitude of the angular momentum at P and Q is not 2amv, sorry, 2mav or 2amv, whatever it is. It's also not true. Why? What is going to be the rate of change in, sorry, what is the difference in the angular momentum? Delta L is going to be like LQ minus LP. If you solve this, MVA common, it's 4 and 1. It should be 3 MVA. So the fourth option is wrong. That's it. That's all about this question. Right, let's get into the next question then. This is a very interesting question. Have a look at it. Yeah, I'll be explaining you the solenoid concept this time. Solenoid concept, we won't be deriving it. It's a very complicated thing. That derive it, but it's not part of your JEE, etc. So might be, I don't know, not relevant to JEE. Okay. So an electron gun is placed inside a long solenoid of radius r on its axis. The solenoid has n turns per unit length, right? And it carries a current of how much? I. It has n turns per unit length. It carries a current of I. The electron gun shoots an electron along the radial direction or the radius of the. Now, with a speed v. Okay. If the electron does not hit the surface of the solenoid, and what is happening in that case, we have to analyze the maximum possible value of v is how much. Okay. Now in this case, we are supposed to assume few things while we solve this problem, right? So yeah, it's a very interesting problem. So we'll quickly get into this. First of all, okay. So first of all, let's understand this thing. We have shot this electron from the center. So here is the thing, it is shot from the center. Solenoid is carrying current in this direction. Let's assume going to be like this, field is going to be like this, right? The field is going to be like this, velocity is going to be like this, some force is going to be in the downward direction, okay, or upward direction. Okay, it can be like current is being carried in this way. What you have to try and understand is, due to this current, the field is going to be either in the outward direction or in the inward direction, right? It's either going to be in this direction field or inside direction. Now in this case, it's going to be perpendicular to the velocity. You shoot it in any direction. Shoot it like this. Let's take a different color for this and understand this thing. Okay, uh, I shoot it here. I shoot it like this. I shoot it like this. It's all perpendicular to B. Imagine the B to be outside the plane or inside the plane. In this case, probably inside the plane, I guess, right? Inside the plane or outside the plane. It should have been inside the plane because this is an electron. Okay, so it should have been inside the plane. That means it should be opposite direction to this. Okay, whatever. Now in this case, what you are supposed to intuit is field is perpendicular to the plane. Electron is being shot from the center. What it will do? It will do a a circular motion. And what can be the maximum radius in this case? R by 2. Maximum diameter is R. Maximum radius is going to be how much? R by 2. Okay. Now that's it. We know the radius, we know every single information that we need. There is one more thing that you should be knowing. I'll be discussing that soon. So what does it mean? Okay, electron charge how much? E, right? We'll be writing it down as not Q but E. Okay, first of all, let's write down the equation the usual way we do. We'll say centrifugal force magnitude and your magnetic field force magnitude should be equal. So it should be like mv naught square. In this case, it is short with v naught speed or something like that, I guess, or v speed. Let's keep it as v naught for now, divided by r by 2. Okay, r is equal to how much? Smaller, I'm writing down it as smaller, is equal to q into v into b. Okay, this also v naught. V naught gets cancelled out. What do we have? M into V naught divided by R. This R is nothing but this, R by 2, right? That's it. So this can be written as M into V naught divided by R by 2 is equal to Q into B, right? We're supposed to find out the value of V naught. So V naught is going to be Q into B into R by 2 divided by M, basically Q R B or Q B R divided by 2M. Q into B into R divided by 2M. Okay, we are not yet finished. Okay, Q, did we substitute the value of Q? Q's value is how much? Q is no more Q, we'll be writing it down as E. E, your charge of electron. E, your charge of electron. That's it. Now there's one more thing that we need to understand. What is the thing? What is the thing that we need to substitute? Okay, let's understand. Okay. The solenoid carries a current I and it has n turns per unit length. If you know this two information, what is the field due to solenoid? It's going to be mu naught into n into that of I. Substitute that value, you will be getting the final value of V naught. Final value of V naught is how much? E into B, that is mu naught into n into I. I'm just substituting this value, nothing else, into R divided by 2n. Okay. That's it. Easy. Okay, now let's get on to the next problem then. A very interesting problem. Okay, this is going to be like a good of revision for your earlier problems. We'll be doing that in this. So there is a small circular loop of conducting wire of radius A and carrying a current I. It has how much radius A and carries a current how much I. It is placed in a uniform magnetic field B perpendicular to its plane. Okay. What is the value of m dot b? It has some potential energy associated with it. And what is the torque? Torque initially is nothing. It's like 0. Right? Both are in the same direction, right? Magnetic moment is and the field is in same direction. Okay. Now what you're doing is like you're slightly like like kind of tilting that wire or rotating that wire about its diameter. Okay, you are rotating the wire slightly about its diameter, and it is then released. It starts to perform like simple harmonic motion. Okay, because one time your magnetic moment is trying to drive it in the opposite direction, and you have given the field in such a way that it is getting back to the normal position. Okay, that's it. So let's understand how to do this. It's quite an easy problem. Just to stay focused on this and you will get the problem very easily. To explain. Okay, now do this problem. Okay. So yes, first of all, this is the condition where current I is flowing, right? And the moment is outside and the field is outside. Probably the field should have been inside. That is not possible, isn't it? V cross E. Yeah. So whatever. Now in this case, what is the torque supposed to be? Torque, let's say you have tilted it by small angle theta. It's supposed to be mb sine theta. Magnetic moment sine theta. And we very well know one more thing. If this loop is carrying current I, what is the magnetic moment supposed to be? Magnetic moment is supposed to be I into A. In this case, it has a radius A. So I into A, which is nothing but I into pi into A square. So this is the value of the magnetic moment. Okay. Now the next thing that you need to do is I into pi into A square into that of B, right? As the value of B being given, no, also perpendicular to its plane. Okay, and what is the angle? Sine theta. Good. This is what torque. Now theta is very small, right? So we can say that sine theta is approximately equal to theta. So we can write down this equation to be something like b into or I into b into pi into a square into that of, instead of sine theta, we can write it down as theta. Okay. Now one more thing that we need to understand in this case to finally get the solution. It's very simple problem, I told you. So this is rotated about what? Its diameter. About its diameter, what is the moment of inertia? M into r square by 2. In this case, it is what? M into a square by 2. This is not current I. This is like moment of inertia I. Okay. So I into alpha is what? Torque. Okay, I am into alpha. Moment of inertia into alpha is your torque. Okay, that is how much? M into a square by 2 into that of alpha is going to be tau. Next thing is, what yeah, this is going to be equal to, and we just derived this thing, torque is going to be equal to I into B into pi a square into theta. I into B into pi into a square into that of a theta, which is equal to this value, m into a square divided by 2 into that of alpha. Okay, we can now comfortably state this thing that which all things are going to get cancelled. Okay. A square gets cancelled out, and what do we have more? We have, this is current I, we have something like 2 into I into B. We'll write down the C. We have alpha, I'm going to write down the value. Alpha is equal to I into B into pi, 2 into, okay, this 2 goes on the numerator, 2 into I into B into pi divided by m into what? Theta. To a small thing over here. And erase alpha, and let's give it name alpha again and theta again. Okay, now focus on legs. Okay. Time period values being asked. What is the time period, students? Time period. Okay, first of all, let's understand this equation. The most important part, I guess, for many of you, probably this until here it's easy. So it's basically one thing you need to know is this is in the form what? This is in the form alpha is equal to omega square. Actually, it should be minus omega square into theta, right? And we also know time period is nothing but 2 pi by omega. Okay, if you have kind of, you know, how this came, etc. So one of the ways to remember this is like using your simple harmonic motion, not your angular simple harmonic motion. What is it? Just let's talk about the case of spring. F is equal to k into x. You remember this thing? So in that case, we say it's like time period is what? 2 pi under root of m by k. Where did that come from? Can we write it down something like this? That means A is what? K by m to x. Just similarly, you can remember this, right? That means what is this supposed to be in that case? Omega square. Similarly, we have an omega square over here as well, right? So this is what? Omega square. You understood it? The time period should be how much? 2 pi into under root of this thing, 1 by this thing, right? Because this is omega square, it should be 1 by root of this thing, because this is omega square, right? That's simple. No other explanation other than that. This is m divided by 2 into I into B into phi. End of the story. Then we got this, right, into I. Yeah, okay, got it. So this pi now can be further cancelled out, right? Pi is, it's going to be root pi, and this 2 and this 2 gets cancelled out. That's not the answer actually. That my mistake. Okay, so this pi and this 2 gets cancelled out. This would become what? Root 2 pi. So finally your time period comes out to be how much? Time period comes out to be 2 under root 2 into m into pi divided by IBI. That's it. There we go. Very simple. Okay. If you don't remember this, what you can do is just get this kind of understanding of this. It will quickly remind you this thing. Don't worry. Okay, let's move on to the next question then. Okay, now we have a very easy question over here. Okay, what is given to you? This is a question that I think very interesting question. It's like an EMA based question, but it comes in magnetic field topic. So let's understand this concept and also quickly solve it. It's very simple. A plane electromagnetic wave is propagating along some given direction in the question. Some I plus J divided by root. With its polarization along, I think it should be electric field polarization. No? They would be not asking us. Electric field polarization along K direction. Okay. The correct form of magnetic field of the wave is going to be what? Let's focus on this. First of all, let's understand what should be the direction of. So two things are over here. Here, if you are able to intuit what is the direction of the magnetic field, first we need to do that. This is of course not true because it is supposed to be perpendicular to I plus J and that of your K, because it's perpendicular to both the direction of propagation and your direction of this thing, electric field. Okay, now comes the next thing. Next thing that we have is this, which it should, right? Both work. That's both works. Both works. Is that it? Yes. No, this one doesn't work. Okay. Answer should just yes. Let's get into the solution and solve it and get the answer. Okay. First of all, let's first of all write down things that we know. Electric field direction is what? Electric field direction is K cap, given to you in the question. Direction of propagation of your light or this wave is in which direction? I plus of J, I cap plus of J cap divided by root 2. Now, what is the direction of your magnetic field? It is supposed to be like E cap cross C cap. Okay, is that it? Yes. Yeah. Right, so it can also be C cap cross E cap, right? So E cross B is equal to C cap, and if I am going to take E cap on that side, it's E dot C going to be 1. Right? Okay, let's solve this. See what do we get. This is going to be K cap. This is correct, I guess. Let's see. Into I cap plus of J cap divided by root 2. Let's write it down neatly because this is the most important step of everything. Okay. Okay. K cap crossed with I cap and J cap divided by root 2, and we can take out the root 2 as common. I mean, first of all, we can take out the root 2, and then what do we have? We are supposed to do some crossing, right? K cross I. I cross K is what? Hope everyone remembers this thing. Supposed to be I, J and K, and this is the cyclic manner it goes. It this we call something. So that means I cross K is going in reverse manner, isn't it? That means it is supposed to be minus J. I hope you know that thing. That means it is minus J, and K cross J, right? K cross I is supposed to be plus J. Okay, and K cross I is supposed to be plus J. Yeah, K cross I is supposed to be plus J, and I think it should be E cap minus C cap, but anyway, it could be also in that other perpendicular direction. It does not matter, and it is K cross J is going to be what? Minus I. Okay, so right, I think it should be C cap cross E cap. I think both would work anyway. So direction of B cap is supposed to be either plus or minus of 1 by under root of what? J cap minus I cap. Next thing comes, whenever we are writing down the equation, okay, you remember, whenever we are writing down the equation, inside that equation we write down something like this: B into some like B naught, or B naught into B cap into that of cos or sine of what we have in this case. In this case it's cos. Okay, so cos of omega t minus kr, right? Kr or C direction. It's nothing but the direction of C. Direction of whom? This guy over here. Okay, so it is supposed to be in this case what? B is equal to like J or I minus J, or it could be also J minus I. Both would work, divided by root 2 into that of what? Cos of omega t minus of I plus of J divided by root 2 into that of K. We need to see which among these options match, right? Okay, so that's how like I was able to quickly say the answer. Solution, that first thing is like omega t minus kr, omega t minus of k into c bar. So in this case, the direction of travel is all of this here, because such questions you are probably not even supposed to do each and every step, rather just reduce the answer from. So k minus k, so minus k, we have minus k over here. If this is minus k, this is supposed to be like minus of this, which is also not true, and this is like fine, and this is also fine, right? And this is also fine. As far as this is concerned, this is also fine, but this is along the direction of travel of the wave, so that is wrong, and this is along the electric field direction, so the answer should be. Okay, hi CS, hi. Okay, now let's get into the next problem. Hi CS, hi. I hope you have started your preparation. I'm good. How are you? So yeah, I hope you're doing also fine, students, and I believe you have started your preparation. So let's get into this problem. This is a very easy problem, very simple problem. Again, we have a damn simple problem. Is okay. Let's start solving it as well. There is a current loop and it is having two circular arcs as you can see. And what is the direction of the current? Exact opposite. Right? And what about the arc size? Arc size is also going to be different depending upon the length and extent. Okay, but we'll be anyway measuring it using the radius. That will take care of. Good. CS. Let's get into this. Very simple concept. Okay. Now, first of all, what is the direction of current in this case? Like this at O. So you need to focus on O. Right? That is where the magnetic field is being asked. At O, due to this, current is like this. It should be outside. Should be outside. Now, in this case, current is in this direction. That means it is supposed to be inside, right? Okay. That is how much? In the opposite. Okay, good. I understood this. Next thing, right? Again, this is outside. Current for the loop, that PS loop, is what? Inside. This one, this what? It's inside, right? Right hand. Now, the next thing that we need to do, what about this wire? This wire is passing through this point. So, no field due to this specific part. Yes, due to that arc, yes. And similarly, even due to this specific part, there is no field. Because it is passing through that point, right? It is on that line joining that, along the line of that wire. Okay. Now, what is the leftover things? One, okay, they are all carrying only 10 amperes. So, those two arcs, QR arc and, like PS arc. First of all, quickly, let me remind you one thing. What is the magnetic field due to an arc? Magnetic field due to an arc is going to be mu naught into I, okay, mu naught by 4 pi into I divided by the radius of the arc into that of theta. Something that you should be knowing by now. The next thing, let's start with PS, right? We'll get started on the next page then. I hope this is clear. Okay, so magnetic field due to PS. I'm going to take the magnetic field due to PS, that is inside, as negative. Okay, so this negative sign is just because of the direction. Yes. And this is what? Mu naught divided by 4 pi into that of what? Current I, that is fine, divided by the radius, let's keep it as like R1, into that of theta. Theta in this case is given to you as how much? 45 degrees, right? It is given to us as 45 degrees. Current value is how much? 10 amperes. Easy. And what about your radius? Little careful around this. Easy to get confused actually. For the reason that we specifically 2 plus of 3. Not 2 or 3. It is 2 plus of 3. It is supposed to be how much? Right. So it is going to be 5 centimeters. Be very careful about this point. If you're noticing, your answer is given in SI units. 5 centimeters, 5 into 10 to the power minus 2. Okay, let's go for the other loop. It's very simple. Again, similarly for other loop as well. The some other loop is this thing, right? How much is this going to be? B of Q into R is going to be how much? Positive. This time I'm taking outside to be positive, right? Mu naught by 4 pi into I divided by how much? The radius R2 in this case, which is how much? Only 3 centimeters. That is straight. Okay, into that of theta. Okay, we know what is theta. Theta is 45 degrees, basically pi by 4 in our case. Mu naught by 4 pi into pi by 4 into 10 amperes. I believe this is 10 amperes. Yeah, it's 10. Is into divided by R by 2. How much? 3. Okay. What is the net field? You add BQ and QR field due to BQ and QR. They are in the exact opposite direction. So you'll be subtracting the magnitude. Okay. So net field is how much? Net field is due to how much? Due to PS. SP, whatever you like to call it, and plus that of QR. First, let's write down QR. Right, I think the space is going to fall short of space. Just do a thing. I'll extend this thing over here. Same equal to. Okay. PS is later on we can look at PS. Maybe we'll start with PS. Mu naught by minus mu naught by 4 pi into pi by 4 into that of 10 amperes divided by how much? And one more thing, this is also 3 into 10 to the power minus 2. Don't miss it out. If we add missed out this thing, our solution is going wrong, right? Completely wrong. Don't ever make this mistake. We have to convert it into meter, so that's why it's 3 into 10 to the power minus 2. Okay. Now this is going to be how much? 10 divided by 5 into 10 to the power minus 2. That's it. Yes, that's fine. Plus of due to BQR. QR, if you remember, it was mu naught by 4 pi into again pi by 4 into again 10, but divided by 3 into 10 to the power minus 2. Okay. Now B net or B total is how much? Mu naught by 4 pi, which is how much? 10 to the power minus 7 into that of like pi by 4 into that of 10 into like 10 to the power minus 2. Okay, this 10 and this 10 to the power minus 2, it becomes what? 10 to the power 3. Okay, can we directly write it down that way? Yes. We are writing down 10 to the power minus 2. We are taken out as common. With this 10, we are writing it down as 10 to the power 3 into how much? 1 by 3 minus 1 by 5, which is like 2 divided by 15. 5 minus 3, right? That is 2. 2 divided by how much? Like 15. Into 10 to the power 3 into pi by 4 into 10 to the power minus 7. Mu naught is how much? 4 pi into 10 to the power minus 7. Mu naught by 4 pi is how much? 10 to the power minus 7. Okay, mu naught by 4 pi is 10 to the power minus 7 SI units. Okay, now let's do the calculation. The ultimate calculation that we have been waiting for, and so let's do a thing. Okay, let's keep this as can I write down this as 10 to the power minus 5 and keep, let's do it on the next page. I hope up until here it's clear. Okay. We don't even have the next page, we would have to sort it out here. Okay. So this is what 10 to the power minus 7, I'm going to write it down as 10 to the power minus 5, just keeping 1 2 aside, into pi, okay, divided by 4 into 10 into that of how much? 2 divided by 15. Okay, 15, this is like 2, this is 3, this is like 4 and 4 goes off, and what do we have? 3 pi by 3. Pi by 3 is approximately 3.14 by 3, approximately 1. So we got our field to be how much? 10 to the power minus 5 Tesla. Okay, and here lies the twist, I guess. 10 to the power minus 5 Tesla. If you hadn't substituted the value of centimeters in meters, you would have got this as the answer. 1.5, but rather 1. The answer. You would have got the answer to be, this is the correct answer that we just calculated. But if at all you had substituted the units to be wrong, you would have got this as the answer. Just totally false. Okay, easy, simple question. Yep. Let's move on to the next question. Again, we have an interesting question. Okay, let's now think about this question different. We'll solve this question using both the methods, like full detailed calculation. We'll also try to guess the answer just by looking at the option. Okay. One of the two identical conducting wires of length L is bent in the form of circular. Okay, so there are two identical conducting wire and it has been bent into a circular loop, right? Other one into a circular coil of n identical turns. So if you are going to bend this, you have only one wire, right? And you're going to bend that wire into, like, like one coil or into n coils, like the same wire into n coils with n identical turns. Which one is going to have lesser radius? Obviously the one that is going to be like, like having n identical turns. One is just, like a loop like this. Other one is you have made n turns. So one with the n identical turns is going to have, like lesser radius. Okay, because if you remember, for a loop, whenever we are calculating the field, we say this: field is inversely proportional to radius. So one with the n turns is supposed to have like smaller radius. The ratio of the magnetic field at the central of the loop BL to that of central of the coil. Coil is with n identical turns, whereas loop is just one circular. Okay. Now in this case, it has n turns as well, right? So obviously your it is going to appear as if it is carrying n current around it, n times current. So and your magnetic field is. Now in this case, BL is of the loop and BC is of whom? The coil. And who should be greater? BC should be greater than BL because it has n turns and it has smaller radius. Obviously, BC is supposed to be greater than that of BL at the center. Okay. Now, in that case, BL by BC cannot be 2 and cannot be 4. Because in that case, obviously, BL would become greater than BC. Now, among these two given options, 1 by n square and 1 by n and 1 by n square, obviously you know that n turns has created that n difference. Apart from that, there is radius as well. So it should be 3, it cannot be 1 by n. Because there is also the radius effect, right? Let's understand the question. That's it. Okay. So first of all, we have a straight wire which has been bent into, like, a coil, and this coil, this L length has been bent into like a coil, and this coil has N turns and some, let's assume, some radius R. Okay. Now there is another like the identical wire which has been bent into a loop. Okay, and this loop has a radius R. Now, one thing that we know for sure is that length of the coil, that is the length of the coil and the length of that loop, is going to be the same. Total length is going to be the same. If L is that wire bent, it should be L. L is equal to how much in this case? 2 pi capital R. That's correct. And for this one, how much it is going to be? 2 pi R, small r, into n times n such, loops are there. 2 pi R, n such loops are there, right? And from there, what do we get? We get something like this. 2 pi gets cancelled out, just working it out for this. R is equal to n into small r. Okay. Next is magnetic field that we need to calculate. Just do remember this thing and we'll move on to the next one. Okay, give it as one. Next. Let's again start with that loop. Coil. Coil is something that we like a lot. And loops, small radius r. First of all, what is the magnetic field due to your one loop? It's going to be mu naught by 4 pi or mu by 4 pi, depending upon medium, into current I, because I is being carried by both the coils, right? Yeah, identical conducting wires, and yeah, current is there. Okay, yeah, same current. If same current is passing through them, so current I is passing through this, so, and through that loop as well. So this should be I divided by small r, right? Small r is the radius. Into that of 2 pi, because here the arc is of 2 pi, into that of how much? N. Why into that of n? Because n such coils exist. N such coils exist, right? Okay, that's it. So let's call this as B1 or B coil in this case. So B coil is how much? B coil is mu naught by 4 pi, or let's write it down, 2 pi. 2. So it's going to be mu n into, first of all, let's write down the n into mu naught I divided by 2r. Okay, now let's calculate it for the loop, which is also easy. It's damn easy, right? Loop is easy, right? Loop is like, what we just did now, just for arc instead of arc, we just did it for coil as well. Okay, loop having some radius r, that's it. It is also carrying some current I. That means what should be the field due to this loop? It should be mu naught by 4 pi into I divided by capital R into that of theta. Instead of theta, it's 2 pi in this case. 2 pi, 4 pi gets cancelled out. So due to the loop, you get a field to be something like mu naught by into I divided by 2 into R. Now, from 1, we initially did a relation between what? Your, from 1, if you remember, what is the value of R? R is n into small r. Using circumference we did it, right? So B of loop is how much? Mu naught I divided by 2 into n into smaller. Okay, I just made this substitution. And it is supposed to be capital N. Let's see. Does not change anything. Okay. Now BL by BC is how much? Obviously 1 by n square. Okay. To calculate this value given to you, what is this common thing that you see? It's something divided by n. This is that something, that mu naught I by 2 per r. If we take this mu naught I by 2 r as that something, what do we get? We'll be getting BL by BC to be 1 by n square. It's a good kind of new problem or new concept that you're learning as well. Okay, let's say you have a wire and that wire is bent into a coil and you're trying to find the magnetic field, and you are again taking that coil and rotating it, so you have that loop and you're rotating it to form a coil. In that case, the ratio of the magnetic field at B loop to that of B coil is going to be 1 by n square, and B coil is obviously going to have more magnetic field because it has n turns, so n amount of more times of current would be appearing. Okay, at the center. That's it. You can just do this once, and I believe this is also clear. So yeah, so I think this was an interesting problem as well. Okay. Okay, now I think we'll pick up this problem in the next session. And what is this problem all about? A particle having the same charge as of electron moves in a circular path of 0.5 centimeter, 0.5 centimeter. So be very careful and just try it out. And yeah, this happens a lot in your magnetism. So under the influence of a magnetic field of 0.5 Tesla. Okay, this is a very nice. If we'll do this problem in the next thing, it is supposed to move in a straight path. You know what to do. QE is equal to QE is equal to QVB. Okay, it's moving in a circular path, so you'll be saying force due to magnetic field is equal to force due to the centrifugal thing. So you'll be getting this as mv square by r. Ultimately, you'll be also having the value of the velocity, you have the value of the radius, you have the electric field value, you have the magnetic field value. That's it. You are supposed to find out the mass of this particle. It's not electron, but the charge is given equivalent to that of electron. You need to calculate it very, very careful while noticing the units, right? We'll be doing it in the next class, so don't worry. So we'll be having this discussion in the next class. So up until then, stay tuned. We have already completed most of your 2019 PYQs. These are actually not 2020 but 2019 PYQs, and we have many more interesting problems coming up. So yeah, we'll be taking up in the next session. We will be soon completing all the PYQs around your magnetism. I believe that is going to be super interesting as well. We'll be discussing the concepts as well. I'll see if your JEE advanced problems are very similar, because there is a lot of variation between JEE advanced problem when it comes to magnetism. We'll be solving that in the next session. And that being said, students, that is tomorrow, right? Friday, tomorrow from 10 AM to 1 PM on your Unacademy learning app, we'll be having a free special class on what? Your 10 years PYQ on current and electricity. Yes. So this is going to be part 4. We have already done part 1, part 2, part 3. A very important topic for your exam. Typically 3 questions are asked from this just specific topic, right? It can be sometimes be more or less. Generally it's 3, and it's on where? It's on Unacademy learning app. And that being said, not only that, we have already also completed on your Unacademy learning app your electrical measuring instruments in one shot. So what is the importance of electrical measuring instruments? Electrical measuring instruments is one of the most asked topic in your JEE Mains and JEE Actually, in your JEE Mains, definitely it is asked. Even in your JEE Advanced, it is asked. So in your JEE Mains, you'll get at least one question from this topic, right? So you're thinking one question from this topic. Should I be doing this topic? But this topic can be completed in 4 hours, students. That's it. In 4 hours, you can complete this topic. Not only that, you can get a full-fledged understanding from this free special class. Yes, we have discussed everything. This includes, galvanometer torque based problem, like how to convert galvanometer into voltmeter, how to convert galvanometer into ammeter, and what is the difference between an ideal ammeter and an ideal voltmeter, and a practical ammeter and a practical voltmeter. Why not voltmeter? Why potentiometer? Applications of potentiometer, like measuring EMFs, comparing EMFs, and also other applications like measuring internal resistance, etc. And meter bridge based JEE Mains, JEE Advanced, like pretty much every like topic based JEE Mains, JEE Advanced problem has been discussed. Along with that, we have also discussed end correction concepts, etc. So do definitely complete it. Only 4 hours is what you need to give to this topic, and you will be able to score at least one question. And students, yes, we have discussed many problems, including error analysis problem, a very important topic. You can also attend this PYQ sessions, because PYQ sessions, if you'll notice, some year had even like some of the students might have even had 2 questions in the paper from electrical measuring instruments. So that way, try to attend the PYQ sessions to get a feel of what kind of questions, to get a gist of what kind of questions are being asked. It's only one lecture, one 4-hour lecture. Definitely do complete it. It's a free of cost special class. And students, do get onto a Telegram channel. First of all, download Telegram app if you don't have one, and then click on to this link which is available in the description box below, and post that you'll be getting onto a Telegram channel where you'll be able to get before time updates on every class conducted by our JEE English team, be it on JEE English YouTube channel or your Unacademy learning app as well. So I keep you posted up with information, etc. And we also keep you posted with information on any latest news regarding your exam syllabus, etc. So you'll be also getting every kind of hot news on this JEE English Telegram channel. And you can also type in JEE_English to find us on Telegram. And that being said, if you are looking for a complete package for your JEE Mains and JEE Advanced, it's going to be Unacademy subscription any day. Why do we say that? Because we have the best educators across the nation with whom you can attend daily live interactive classes. In fact, we have authors of your book like DC Pandey and DC Gupta sir, who are teaching on our platform. And not only that, you'll be attending these classes on a very interactive platform with polls and leaderboards. That way your learning becomes very interesting. And not only that, we also provide you lots and lots of test series. And along with that, you'll also get access to the analysis of this test series. These test series are set by the best educators, and using this analysis, you can improve upon your performance. And students, you will also get access to lots and lots of live doubt clearing session on Unacademy subscription platform. And in fact, your every program is going to have live doubt clearing session. In fact, your every 4th session is going to be a live doubt clearing session, so that you're able to maintain completeness. And every program is well structured. You don't have to worry about the planning. It comes with all the kind of live doubt clearing sessions, quizzes and mega quizzes. And moreover, Unacademy subscription provides unlimited access throughout the period, and you don't have to worry about batch restrictions. There are no batch restrictions on Unacademy subscription platform. And yes, so we'll be starting fluids very soon. We'll be completing gravitation, probably just quickly going through any kinematics PYQs, and we'll be completing magnetism PYQs, and probably taking up AC current or semiconductors. One among those we'll be solving, and then we'll be moving on optics, or we'll start with optics, and then we'll go to the rest of the topic. Okay, we'll do some optics PYQs after this. Your magnetism PYQs will soon end, students. Probably I think 3-4 more sessions your magnetism PYQs will end, and post that almost your 2019 PYQs we are about to complete it. That's like too many questions up until now, like these many magnetism questions. If you solve them along with the concept, like we are completed, I think we have revised sort of like the formulas, etc. But also we have done different kind of concepts on your magnetism. So we are about to complete your magnetism PYQs. We will get started with fluids later on, because fluids is not so much of an important topic for you from exam perspective. So we'll be choosing optics probably after your magnetism, and also in terms of your First year topic will be choosing kinematics, and we'll do like a PYQ concept and problem session kind of thing. And students, do not forget to apply Murli Live code whenever and wherever necessary. Also, you can apply it on an academy subscription. But post, but once you are on an academy program page or your payment page, you will see multiple programs. Which is that program that is meant for you? Let's say you are a 2021 aspirant. I hope I answered your question. And it's going to be a 6-month program, and a 6-month program is going to cost you near about 25,000. And let's say you are a 2022 aspirant, you may want to go for a 12-month program. If you are even a 2021 aspirant and probably are going to drop, you may want to go for a 12-month program. A 12-month program is going to cost you less than 35,000, 34,650. And let's say you are a 2023 aspirant, you may want to go for a 24-month program. A 24-month program is going to cost you 50,400 for 2 years. That is going to be 25,000 per year. That is less than 70 rupees a day. So this is about a plus subscription. We have something beyond plus subscription known as iconic subscription. On iconic subscription, you can get one-on-one mentoring session, like personal coaching from IIT and NIT alumni who are educators on our platform. So think about it, IIT and NIT alumni who have previously gone through this journey and successfully cracked the exam knows the ups and downs in this journey. They'll be guiding you with the motivational sessions, strategy sessions that can aid you in successfully cracking your exam. And if you can afford it, it's going to be one of the best things. And how much is that going to cost you? A 6-month subscription is going to cost you 34,200, and a 12-month subscription is going to cost you like 58,500, and a 24-month subscription is going to cost you 90,000 for 2 years, 45,000 per year. And students, yes, do not forget to apply Murli Live code, be it you go for Iconic Plus or also combo subscription to get the maximum discount. Yes, students, yes. That being said, we have recently also introduced something known as combo subscription. What is this combo subscription? A combo subscription is nothing but an economical package for both your JEE mains and your CBSE board preparation at an economical price. So you can prepare for your JEE and CBSE board preparation, CBSE board at an economical price from anywhere across India. Not only that, students, you can also get this classes in different combinations of this combo subscription as well. You can go for iconic of IIT JEE, plus of CBSE, full iconic, that is iconic of IIT JEE, iconic of CBSE, and you can also go for CBSE and IIT JEE plus, and you can go for CBSE, iconic and IIT JEE plus. And how much is this going to cost you? It's going to cost you 3,037 per month. So this is where the starting price of it, and it can go as low as less than 90 rupees a day for 1 year 2-year subscription, and less than 120 rupees a day for 2-year subscription. And make sure you also apply Murli Live code on combo subscription if you're availing combo subscription to get the maximum discount on your subscription purchase. And that being said, students, yes, we are on Iconic subscription. Our JEE English team is on Iconic subscription. You can take your JEE preparation to next level. With our Iconic subscription, we will provide you the IIT JEE workshops, give you the expert guidelines, study planners, test analysis, etc. So yes, do not forget to like and share this video, and definitely make sure you are sharing it on social media like WhatsApp, Facebook groups, Telegram channels, etc. Like also on your Twitter, because it's a free of cost initiative and academy where you get not just lectures but high quality full length lectures. So do share it, do click on that subscribe button and bell notification so that you will be getting the updates. And yes, students, keep smiling, work hard and smart to achieve your success. Keep smiling, avoid any gossips. And tomorrow at 10 a.m. right? 10 a.m. on your Unacademy learning app, right? We'll be having your current and electricity session, PYQ session on current and electricity. Don't miss it, right? And yes, you can follow me on an Academy Learning app to get the updates. And that being said, make sure you apply Murli Live code not only to get maximum discount on your subscription purchase, but also to unlock any feature on an Academy subscription platform. It can be this combat coming this Sunday, and you can attend it by applying Murli Live code totally for free of cost, and you can unlock many features. You can get the maximum discount. You can avail the maximum benefit. Take care, stay safe. See you in the next class. Yeah.